Everyone, and welcome back to lesson 23-2. We're going to continue talking about the sum and difference identities. Yesterday, we had the sum and difference identities, and again, we talked about following. If it's a plus sign in here, it's a minus sign up here. For cosine, minus, plus. Sine, it's the same sign, and for both plus and minus, and then tangent, it's the same in the numerator, but different in the denominator, depending on what you're looking at. And alpha and beta are just like saying x and y. Sometimes you'll see it represented that way. Okay. Now, we're continuing on page 308, I believe, on this one. And the bottom of page 308, where we left off in the last lesson, we see these triangles drawn in. And remember, depending on where they're telling you your location is at quadrant-wise, is where you would want to draw in your triangles. Now we have two different triangles because we're talking about two different angles, alpha and beta. And beta, they are telling us is in quadrant 4, and alpha was in quadrant 1, between 0 and 90. And they're telling us the cosine and the sine, which are going to tell us the adjacent over the hypotenuse in alpha, and then opposite over hypotenuse in our beta. And we can identify either the base of Pythagorean triples / use Pythagorean theorem to find the missing sides that were not there. Now from there, if we want to find the cosine of alpha plus beta, we're going to use that sum identity that we talked about. So cosine alpha times cosine beta minus sine alpha sine beta. And using the trig ratios from our picture, we are going to substitute those in. So we're using cosine of alpha, which they actually gave us, but adjacent over hypotenuse, times sine of beta, opposite, or cosine beta, which is adjacent over hypotenuse, and then sine alpha, times sine of beta, which is -5/13. And then we're going to simplify those values, each one, and then add them together for a total of 56/65. Okay. Now, on the next page, we have our examples. Now, I'm going to let you know right now that they are not giving you a ton of room, so make sure you either write really small, or you might want to be using the margins and the mind notes for these, okay? So in this first problem, well, really actually in both of them, we have alpha will be in quadrant 1 and beta will be in quadrant 2. So alpha would look like this, and in this case it's opposite over hypotenuse, 3/5, and our remaining side is 4. It's a 3, 4, 5 right triangle. We could also identify that as a Pythagorean triple, or use Pythagorean theorem if you did not know that. Then we have beta, it says, is in quadrant 2, and they gave us the tangent, so the opposite over the adjacent. So 8 and 15, and the negative is going to be with the 15 since we would have to move to the left, okay? Now, if we look at our first triangle, if we look at the sine, they gave us that of alpha. That's 3/5. Cosine of alpha is going to be 4/5, and tangent of alpha is 3/5, or 4, excuse me. Opposite over adjacent, right? Setting up these trig ratios. Same idea here. We know that this is going to be 17 from Pythagorean theorem / it's a Pythagorean triple. So we have opposite, adjacent, hypotenuse. So for beta, the sine of beta is opposite over hypotenuse. Cosine of beta is adjacent over hypotenuse. And the tangent was actually given to us, which we know is opposite over adjacent, then negative, okay? So now, if we're looking for the sine, the difference here, or the tangent sum, we're going to use our formulas that we've been talking about now. So we would say, okay, we know sine of alpha minus beta, right? We know that that equals the sine of alpha times the cosine of beta minus, same sign, cosine alpha sine beta. Right, going back to our formulas. So the sine of alpha is 3 over 5. The cosine of beta is negative 15 over 17. The cosine of alpha is 4 over 5. And the sine of beta is 8 over 17. Now we simplify this. I always recommend doing it as two pieces. We have 3 over 5 times negative 15, 17, and then minus for this. Which, this decimal, but again, we want to turn it into a fraction. So negative 77/85 would be your final answer. Now, tangent can be slightly uglier because we know that the tangent has a fraction involved, right? If you're doing alpha plus beta, we know that that's tangent of alpha plus tangent of beta, and then 1 minus tan alpha times tan beta. So tangent of alpha, we said, was 3 over 4, plus tangent of beta, negative 8 over 15, and then 1 minus tan alpha is 3 over 4, tan beta, negative 8 over 15. Okay, now this is where I would definitely recommend in your calculator 2 steps. Okay, one being the numerator, so 3/4 plus negative 8/15, and fractionally that is 13/60. And then I would do this as 2 steps because otherwise you're going to need a fraction within a fraction. You want to make sure the order of operations is right. So now do the denominator, 1 minus force negative 8 1.4 or set this. Now one last step, divide 13/60 by the 7. This your final answer of 13/84. Now, the next one then is going back to saying that alpha was in quadrant 1, beta is in quadrant 2, just like we have up here. And we have alpha and beta now. Alpha is again in quadrant 1. So we have opposite over hypotenuse given this time. So this time it is not a Pythagorean triple. So we're going to have to use Pythagorean theorem to find this. So c squared minus a squared equals b squared, right? So 9 minus 1 is 8. So we end up with the square root of 8 here. And then again, we know that beta is in quadrant 2, and this time they're giving us opposite over hypotenuse. So 3 and 4. So again, this is not a Pythagorean triple. So c squared minus a squared equals b squared. So 16 minus 9 is 5. The square root of that would be our value there. And again, it's negated because move to the left. Oops, I'm so sorry. 16 minus 9 is 7, not 5. Okay. Now, similar to what we did last time, it's often helpful to have your ratios set up so it makes things a little bit quicker if you're plugging in. So sine of alpha, we said was 1/3. Cosine alpha then is square root of 8 over 3. And tangent of alpha is 1 over the square root of 8. Okay, which we can rationalize if needed. And then for sine of beta, we were given it was 3/4. Cosine of beta then negative square root of 7 over 4 tangent of beta, opposite over adjacent. Again, we can rationalize later if we need to. So this time for the sine of alpha plus beta, again, we know that that's sine alpha cosine beta plus cosine alpha sine of beta. So in this case, sine alpha 1/3, cosine beta negative square root of 7 over 4, and then cosine alpha square root of 8 over 3 sine beta negative, positive 3 over 4. And as we simplify here, this one you probably are going to want to ignore your calculator because you don't want the rational getting involved. 1 times negative square root 7 is negative square root 7. 3 times 4 is 12. Plus square root of 8 times 3 is 3 square root 8 all over 12. And officially, this one's not going to really simplify to be very pretty. We can break down the square root of 8 to be 2 root 2. So basically the best we're going to get on simplifying this one is going to be 6 square root 2 here. So negative 7, square root 7 plus 6 square root 2 all over 12. Can't simplify these two because we don't have anything here that simplifies with the 12 as a side note. Okay. Last example then with cosine of alpha plus beta. With cosine alpha plus beta, that's going to give us cosine alpha cosine beta minus sine alpha sine beta. So cosine of alpha, we said, is square root of 8 over 3 times cosine beta, which is negative square root of 7 over 4. And then we have minus sine of alpha, which is 1/3. And 3/4 is the sine of beta. So multiply here our radicals, we end up with negative square root of 56 over 12 minus 3 over 12. And we can break down the square root of 56 because it is divisible by our lovely perfect square of 4, right? Think about our factor trees. We have 4, 4 goes into the tens. So we end up with negative 2 square root 14 minus 3 all over 12 will be our final answer on that one. So again, we will work more with these prep problems in class. Make sure again that you have this list handy for while we're working in class. Thanks everyone.